Hello Internet. Today we're going to be making Flappy Cube. This is sort of the intro to Unity project that when people want to learn Unity, this is sort of my go-to project. Because the idea is we're going to be making Flappy Bird. But we're not going to use any art or anything. We're just going to use cubes. And all of it is going to be, we should be able to get it done in about 30 minutes. So hopefully we'll get into coding, we'll get into a little bit about Unity, and then from there we can expand upon that. So the idea of this is to kind of be a crash course into some of the features of Unity and how to use them. So when you start, you're going to get this. This is your project thing. If you're new to Unity, all of these projects are going to be empty. So if you want to get started, just click new over here, give it a name, call it Flappy Cube. It's going to be a 2D project because you're only working in 2D. So just because you select 2D doesn't mean you can't use 3D models or anything. Everything in Unity is in 3D. This just changes a few of the editor settings. So it'll change like your default camera, for example. So we're going to select 2D. I'll keep analytics on. I'm not publishing it. If you don't want to collect user analytics, turn this off. And then just hit create project. And there you go. Unity is going to fire off now and do its thing. It's going to open up all of that. And now we should get this wonderful white screen. I am using Unity Pro, so black. If you're just using the free version, you're going to get a lighter gray color. That's fine. There's no difference there. It's just different color. And then now that you have Unity 5, I think is when it happened, they gave you pretty much every feature that you get in Pro. It's just a bunch of the enterprise level stuff. One thing I'm going to do quick, because you see I have this empty window here. It's actually throwing some exceptions. That's because I usually run Pro Builder. Pro Builder isn't installed right now. So I'm going to do that, and that's going to reset my window. Just click Window, Layouts, and choose one you like. I use the default. A little bit of a modification of the default, but still the default. So we have this basic scene. Since we chose 2D, there's no light created. And we get an orthographic camera, which means it's doing a square projection. It's not doing a perspective-based projection. And the difference between those is if you look in 2D, you'll see this goes in a cube and then goes straight. Whereas if we do a perspective view, it starts very thin and kind of stretches out. So if you're looking for that classic like Diablo style, you're going to go with an orthographic view. Or if you're just looking for 2D, it means you can have different depths and things will still look the same size. If you use perspective, things are going to get a little bit weird. So just keep that in mind. Our camera is set to use the skybox, and that is totally fine for now. We can just keep that on. Let's see, what else do we need? Let's create a new folder down here. So down here is our assets. This is everything we can use in our project. All of our scripts, all of our objects, everything. So I'm going to create a new folder for that and just call it Flappy Cube. And now the reason I do this is because if you start using like Unity's asset store, for example, all of those are going to import into their own folder. And so this kind of helps keep everything a little bit isolated. So if you start importing other people's stuff, it doesn't overwrite your own stuff. So for example, like camera controllers, which are pretty common, you don't want that to be overwritten. So anyway, that's why I do that. We've got a scripts folder. I call it scripts. It's where I put all my scripts. I think that's fairly straightforward. And then I like to either call it prefabs or resources. And there's a difference there. Unity has a keyword for resources. So if you're using resources, it's going to actually compile that into a package that you can reference from code. If you don't need that, I don't do it. I don't know if there's any benefit to that. It's just what I do. So if you want, I would recommend reading up on that. But for now, we can work with this. We're going to just create a 3D object and create a cube. And there's that. And then I'm going to give it a box collider. So you can see we get this green outline, and that is our box collider. And that's actually going to collide with things in our scene. It isn't going to collide with anything yet because we don't actually have anything yet. So the other thing I'm going to do is I'm actually going to re-add the directional light. And that's because we are using 3D objects for this. So even though we are using even though we're making a 2D project, we have 3D objects with 3D lights and all of the advantages of 3D. We're just making it in 2D. So this cube is going to look just like flat. You're only going to see this front of it. All the other sides aren't even going to draw. But we're going to make it 3D and lit because we can. I guess that's as good a reason as any. So I'm going to create a new scenes folder. And usually my first scene I call like test or something. And that's usually just where I'm getting everything sort of laid out. Usually when I'm making a game, I'll test it first, kind of really hack together a bunch of stuff, see if it's a little fun. If it is, then I'll finish it. If not, then do something else. So we have this. So if I run our game, just click the play button up there. It'll run in this editor. It actually has two separate views, so I can go into the scene or into the game. One of the cool things is I can actually use both at the same time. So I can actually manipulate objects in my scene while my game is rendering, which is super cool. It's super handy to be able to do this because all of these scripts can be modified. So I'm still running my game. I can change my colliders on my objects so they'll collide differently. I can apply different things. I can stick a new material on here. I can do whatever I want. So this is really handy when you're trying to like debug something, for example. The disadvantage is it can get a little bit slow. So your game is going to perform worse when you're in the Unity editor. But I'm pretty sure that's the same for any in-editor editing thing. I said edit a lot in that sentence. But anyway, moving on. We have a cube. It doesn't do anything. That's kind of a problem. So what we want is we're actually going to physically simulate this because we have Unity and Unity has physics. So I'm going to add, oops, we're still running. And I guess that's a good example. So I just added a Rigidbody, which is just a physically simulated object. So there's two different things to get physics working. You need a collider, which is this box collider, but you also need a Rigidbody. And you'll notice they're both 2D objects. So the Rigidbody is what is actually going to track velocity and weight and angular momentum and things like that. Since we don't really want it to rotate, I'm going to actually constrain that. So this means it will be simulated physically on the X and Y axis, but it won't be simulated. It won't acquire rotation if you hit like the corner of something. So that kind of helps there. What else? I think that's it. We don't really care that much about mass or anything. We can fudge those numbers if we need to. So we've got a box and we've got our Rigidbody. Now, what we want is when you hit the space bar, let's say, we want it to jump up. So I'm just going to go and create a new C# script. You can create either C# or JavaScript scripts in Unity. Either one works. And if you really want to get into it, you can actually get them to work together. So you can actually run your JavaScript stuff to run C# stuff, to run your JavaScript stuff, to run your C# stuff. I don't recommend it because it gets really confusing. But if you need that, if you have a plugin, for example, that is using one and you need the other, you can do that. I won't cover that here because that's more of an advanced thing, but we'll get into this. So I'm just going to call this the flight controller. And all this is going to do is attach to our cube, which we'll call our bird. And I'll save that. But so the flight controller is just another component. I'm just sticking it onto our bird. There's nothing unique about that. It's just Unity is a component-based system. So everything here is a component. You've got a mesh renderer. You've got a cube, which is the actual mesh. You've got a box, a Rigidbody, and then you've got this new flight controller. So the idea is you build a bunch of components, stack them on top of one another, compress them all, and then there's your object. So it allows you to create very modular things, very small and lightweight things, and then combine them together to create something really cool. So we've got a flight controller. I'm going to actually open this. I have it configured to open Visual Studio. You can do that through here. Where is it? Preferences? Yeah, external. If you go into this external tools, it's not going to let me because it's got this dialog open. But that's kind of weird that I can move it around, but I can't actually click into it. But if you go into external tools, there's ways to change how you do image editing or anything like that. I set it to up to use Visual Studio. I think the default is some version of Mono developed that Unity forked a long time ago, which is fine. It does what you need. But if you want, Visual Studio support is included, and you can actually add that during install. So it's an option. And Visual Studio is free now, so go for it. Let's see here. It's going to load up, and this is going to be our basic mono behavior. So all of those components I was talking about, they're mono behaviors. That's just think of it as like a component. So what's the best way to describe that? If you're thinking about a car, your car is going to have a bunch of different parts. It's going to have wheels, it's going to have a steering wheel, it's going to have chairs, keys, things like that. All of those have different things that they do. For example, your wheels are going to drive forward, for example. Your components, you want them to be that kind of thing. You want them to handle those kind of things. It's hard to describe, and it's kind of more something you kind of pick up on as you start working with it. And I'm not to the point yet where I can describe it in a way that other people will understand, which I guess I'm sorry for. But think of these mono behaviors as certain capabilities of your object. So for example, this one is our flight controller, which means it's just going to handle flight. If we need to add other controls like special effects or power-ups or health or any of that, we can do separate components for that. So what I'm going to do is I'm going to require a Rigidbody. And so all you do is use a C# annotation with the type that you want. And you need that special type of keyword or this doesn't work. And all this is going to do is say whatever game object I'm attaching this to, it needs a Rigidbody attached to it as well. So if I do Rigidbody 2D, what we're saying is if this component doesn't have a Rigidbody, add one. And I believe Rigidbody requires a collider, so if you don't have a collider, it will add that as well. And you kind of get these dependencies between them. So what we can do is we can add a reference to that Rigidbody. We'll just call it the body, I guess. So we've got our Rigidbody here. And what we need to do now is when we start, we want to get the component from the object. That is not how you type that. You're going to get the component of type Rigidbody 2D. And so what this is doing is it's looking at the current object you're attached to and checking if there's another component attached to that object that is of the type Rigidbody 2D. So that's why we needed this, because otherwise this could not return anything, and then you get a null here, and then none of your stuff works, and you wonder what's going on, and it all falls apart. So if you do this, it's pretty easy. There's another way to do this that's even easier, actually. If you just make this public, like I'll do now, if I actually go back to Unity, you'll see what happens pretty quickly. Yeah, okay. We'll jump to this quick. You can see it's set to Visual Studio. We've got mono develop built in, and there's a browse for others. But that's, yeah, going back to what we had. But the cool thing is, I made this thing public, and so now it's showing up actually in Unity, and you can just change it here. I can just click and drag, and it's done. We don't need that Git component. We don't need anything. I personally, if it's something that's going to be required, I probably am going to use the Git component. And the reason for that is, what is the reason for that? It's just sort of personal preference, and it also kind of keeps things contained. This way your references kind of stay where you want, and you have sort of a static or standard build of something. I've seen people prefer one or the other, and honestly it kind of switches for me depending on the project. But for now, this is what we're doing. Not for any reason, just that's what I'm doing. Anyway, I've talked about that too much. So what I want is, right now we have a bunch of gravity applied to our cube. So we want to add force. And so this body has a bunch of functions for adding force to it. And hopefully we can just add an upward force. And this is just going to take a vector 2. We're in 2D space, so it makes sense to only accept a 2D vector, which is either going to be x or y. And then you just add force. We're also going to multiply this by the delta time. And now we have some upward force. This probably isn't enough to counteract gravity, but it's something. So yeah, it still falls. But what we can do is if I turn off gravity, I change this gravity scale to 0, so gravity is not applied at all. We should see it slowly start to rise. There it goes. So you can see the cube is slowly rising, which we obviously want more force than this. This is puny, but you're getting the idea. We're making the cube go up. And so with that basic script we wrote, like that, this one line, we were able to apply force to an object. So we've got a physically simulated cube, and it goes up. Whoop-de-dee. What we can do now is we can use that public trick. So I'm going to expose the force and give it a default value of like 100. And then we're actually going to do, let's say 10. I'm going to remove this constant force. And then I'm going to wrap this in a test. So we're going to do if the input, which is just a Unity static object for getting inputs, and we're going to get a key down. So when this key is pressed down, we're going to do the spacebar. Then what you want to do is add an upward force, or add a force equal to the force time, let's add equal to the up force, up vector times the force. Sorry, I'm walking all over myself today. So the idea is, if we press space, add this force. And since this is only going to happen when you press the button, we're taking out that time delta because this is only going to be a one-time thing. So if we go here, we should be able to stay up in the air. Or not. May have lied. I think I lied. Okay, so that didn't work. All right, let's drop this down to 0.25 so we drop a little bit less fast. Okay, still not working. So we could be changing these values constantly in the editor while we're running. The issue with that is it's going to end up getting quite a bit of force because we're doing physics simulations. No, okay. Sorry, that's probably going to sound terrible on the mic, but what we're trying to do is we're kind of trying to tune this force to match this gravity, which is going to be 9.8 down, I believe. Yeah, there we go. So we get sort of this. So if I press it, I go up, and then I fall down. And I press it a bunch and go up, then fall back down, and so forth. So this kind of gives us a really basic up and down thing. Nothing too complicated here. But I think that's, yeah, I think that's it. So this gets us to a really basic like flying, but it doesn't do it right. So what we're doing here is we're doing a input get key down. There's a better way to do this, and part of that is not to use this. So Unity comes with a, let's find it, with project settings input. So this whole mass of things is going to be the default inputs that Unity accepts. So if you've ever played a Unity game, you've seen the default launch screen that has like the game names with the settings, which are like fantastic or great or whatever. And then it also has an input thing. That's where these come from. So if I tune this down to just one thing and we say fly. Yeah, we'll call it fly. And then we have a negative button and a positive button. So the positive button we just want to be space. We don't want any alternatives. So you can have a negative, a positive, and then an alt for each of those. So you can bind 2 buttons each to each of these. The classic example is like if you want WASD and the arrow keys to move you, that's what this is for. We just want the space bar. So there's also a gravity, which is going to affect how fast it gains its power. You can just turn that up. And then there's a dead zone. So if you're using like a joystick on a controller, at the very center you want some sort of dead zone. So if it doesn't get all the way back to 0, you don't slowly start moving. So that's that. And this, speed to move towards target value for digital devices. Is this not what I wanted? Yeah, okay. So there's 2. The sensitivity goes one way and gravity goes the other way. It's actually been a while since I've looked at these. So I use a plugin usually for inputs. So I'll wave my finger a bunch and then I'll shake my head because I don't know what I'm doing. But this should be good, and I think the snap is going to override that anyway. Oh, no it's not. Snap is going to be, say you're walking one way. Say you're walking forward and you want to turn around and go back. There is a sensitivity and a gravity that are going to affect how fast those move. And so what snap is going to do is if you didn't have it on, you would kind of coast forward a bit before you started going back because it would round down. This is going to immediately turn you around. So there's that. And then the type, we can set it to just a key. We've got space. It should all work. Then all we need is to switch this. And this is now going to be a get button down. And then we just give it a name. No, that's wrong. Is it wrong? Hold on. There's a few ways to do this, and I'm confusing them. Might not do that. So there's 2 things you can do. There's get button, which is going to be the name of a button if I remember correctly, and then there's get access. And I'm thinking that get access makes sense, but I feel let's find out. So we've got get button down. That's the wrong one. That was get key, get button down. And we'll just give it fly. I think this is expecting like space or some other actual key name. So I don't think this is going to work, but if it does, then that's the way you should do it. I was thinking we would have to use the axes, but I could be wrong there. So we're going to find out. I was wrong. So if you need just one button, like we're doing here, then use get button. If you need like walking, for example, use a get axis, and that's going to return you a float between whatever, -1 and 1. And you can use that to kind of move around. It's great for controllers and stuff. So this works. We have flying. It's actually super simple, and it's bound to the inputs. So when somebody starts, they can rebind this to whatever they want. So that's pretty cool. And it took us all of like 15 minutes, 20 minutes. I don't actually know when this started. I should know that. Anyway, this is like, let's stop here, and this will be part 1. And then I will pick up, and I'm probably going to publish these back to back anyway, but I'm going to report it tomorrow. Anyway, doesn't matter. I'm going to stop here, and tomorrow, next video, we're going to pick up and we're going to actually add collision detection. So you can actually see when things get hit, and maybe we'll even have some fun with it. So that's all for now. If you guys liked it, leave a comment and let me know what you like, what you think. Yeah, I'm curious. So yeah, hope you guys enjoyed it, and until next time, see you, internet.